All right, guys. So today we are going to be starting lesson 2, investigation 1, modeling chemical bonds, molecules, and extended structures. We are going to be using our paper student interactive notebooks. We're going to be on page 22 and 23. So if you don't have that handy, go ahead and pause this video so you can go get it. And then also make sure you have a pencil to write with as well. All right, let's get started. So most substances that you encounter every day are composed of molecules. You, your classmates, and many of your classroom materials are made of atoms bonded together to form molecules. Just like atoms, molecules are too small to be seen with only your eyes, so scientists use models to visualize them. Why do you think it might be useful to use a model to examine something very small? Not all atoms make chemical bonds. The noble gases, such as helium, neon, and argon, do not typically form bonds with other atoms. But most atoms are not stable unless they are bonded with at least one other atom to form a molecule. So a molecule is when we have a group of two or more atoms that are held together by a chemical bond. That means they're actually connected with each other. We actually have a molecular modeling set that we're going to be using to create some models of different molecules. Okay, so here's what that looks like. And on the inside of the lid to this set, we have the key. Okay, you can kind of see the same picture over here on the right-hand side. We're going to take a minute, we're going to examine our kit. We're going to see the different types of objects that are in the kit, the different colors of the different objects, and see what those colors represent. Let's pay attention to the color, the size of the different colored objects. So we're going to be making some qualitative observations of the different pieces in this modeling kit. And we're also going to see some rods and sticks and look at those too, if they're different colors or different maybe shapes, different lengths. Okay, so let's go ahead and take a minute and do that. So over here on the left-hand side of your screen, um, let's pull up our molecular modeling set. Okay, and you'll see that we have, there's actually some blue ones too that I have been using. You'll see that we have all different kinds of colors, right? I have a small white, green, and kind of metallic gray colored spheres. And then I also have some larger yellow, black, red, purple. Here's some blue as well. Okay, so we have all different colors and there's different sizes of these spheres as well. And in addition to that, I have these rods over here, these sticks. And you'll notice some of them are short and some of them are very short, right? And then some are kind of a medium length. And then we have these longer ones over here too. And the longer ones they have like a bend to them, a little give to them. Okay, so chemical bonds. When atoms connect with other atoms, a chemical bond results. Chemical bonds are responsible for the large number of molecules found in nature or created in laboratories. Look at the model atoms in your molecular modeling set. Then complete the chart in your notebook. All right, so on page 22 in your notebook, we have a chart that we're going to be filling out. Okay, this chart is asking us to take a look at hydrogen, oxygen, nitrogen, and carbon. So I'm going to go ahead and pull those atoms out. And how I know which atom is which is by this key. And there's a picture of this in your module for this week as well, so you can see this a little bit more close up. And you can also refer to it later as well. So on the key, here's the first column on the left is where I'm going to see the different types of atoms. And they put both their chemical symbol, which is the symbol that you would find on the periodic table when you're looking up that element. And they also put the full name, okay? And so we need to take a look at hydrogen, which is white. So let me pull that one. We need to look at carbon, which is black, and nitrogen, which is blue. one out. Okay, so that blue one. And then also oxygen, which is red. Okay, so let's take a look at those for a second. So the very first one it's asking us to look at is hydrogen. Okay, so hydrogen, that is our white sphere. It's a smaller one. And we also need to figure out how many possible bonds this can make. And you can use your key to help you. So if I take a look at this key over here on the inside of the lid, I can find hydrogen. It tells me it's white, right? So that's how we know it's this one. And it also tells me how many bonds it will make, and it says 1. And if I pay close attention to this atom, I see there's only one indentation or area where a bond can be formed, right? The rest of it is just smooth. Can't make any other bonds on there. So let's go ahead and record that information. So hydrogen is white, and it can form one bond. Make sure you're writing this down as well. Okay, the next one we need to take a look at is oxygen. Okay, and that one's red. Again, I'm going to use my key that's in the inside of the lid. And here's O for oxygen. That's a chemical symbol. Tells me it's oxygen. Tells me it's red. And it also can only form 2 bonds, right? So if we take a look at this actual atom, the model of the atom, I see that I have 2 areas where I can possibly make a bond form. So let's record that information. So oxygen is red, and it can form 2 bonds. Next up, we have nitrogen. It's blue. Using my tools again, that key. And if I go find nitrogen, N is for nitrogen, I see it listed twice. And what I notice the difference between each of those is this one says it can form 3 bonds, and this one says it can form 4 bonds. So that means I have 2 different kinds of nitrogen in here. One that has 3 areas to make a bond, and another one that has 4 areas where I can make a bond. So let's go ahead and record that. Nitrogen is blue, and it's 3 or 4. And then last up on our list, we have carbon. Carbon's black. Grab my tool again. C for carbon, that's the chemical symbol. 4 bonds, and it's black. Let's take a look at the actual model, and I see I have 1, 2, 3, 4 areas where I can form a bond. All right, let's record that as well. Oops. Black, and I can form 4 bonds. Okay. So now we're going to talk about some simple molecules. Remember, a molecule is when we have at least 2 atoms bonded together. So now we have a new substance that's formed. We have a new molecule. And the simplest molecules are composed of only 2 atoms. And those atoms can be either the same type of element or they can be different elements. Scientists often use chemical symbols to write the names of molecules and substances as a chemical formula. Subscripts are used for when we have more than one type of atom that's in that chemical formula or that molecule. So for example, hydrogen gas right here is H2. So what I can tell from this chemical formula right here is that I have hydrogen, right? Because that's the chemical symbol for hydrogen. If I were to go onto the periodic table of elements, I would look up the H in order to know that I'm talking about hydrogen, okay? And then I have this little baby number 2 right after the H, which means it's a subscript. And what that subscript is telling us is that we have 2 hydrogens in that molecule of hydrogen gas. The same thing applies for oxygen gas. So we have the capital O because that's the chemical symbol for oxygen. And then we have that subscript right after the O, and that's telling us that there are 2 oxygens bonded together in a molecule of oxygen gas. And you can actually see that up here, right? I have 2 oxygen atoms and they're bonded together. So the way that I write that in a chemical formula is using the O for oxygen and putting the little subscript 2 to tell me that there are 2 atoms of oxygen bonded together. Nitrogen gas is also similar. It's N2, so N for the chemical symbol for nitrogen, and then we're using that 2 as a subscript to tell us that there are 2 nitrogens chemically bonded together in that molecule. Now let's take a look at nitrogen monoxide right here. So nitrogen monoxide, NO, that's the chemical formula for it. I don't see any subscripts after either of those chemical symbols, N or O. And the reason for that is because I only have one nitrogen atom and one oxygen atom bonded together. So I don't need to use a subscript, right? Subscripts only tell us if we have more than one of that same type of atom. All right, so in your notebooks, on this side, there we go. And now I'm on page 23. We're going to actually be building these molecules with our model set, so you can take a look at them. So find my hydrogen gas. That's the first one up here, okay? And hydrogen is represented by 2 white spheres. And remember, hydrogen can only form one bond, so there's only one stick in the middle connecting them. So this is my model for hydrogen gas. Remember our chemical formula, H2. H is telling us the type of element that's in here, which is hydrogen. And we have 2 of them, 1, 2. Okay, so how many different elements do we have? How many different colors do you see in this model of hydrogen gas? There's only one, right? There's only white that's being used. So we only have one type of element. How many atoms do you see? How many specific spheres do you see in this model? I see 2. 1, 2. And the total number of bonds in this model of hydrogen gas? Just 1, right? So we'll put a 1 there. Okay. Now you're going to do the same thing for the other models here. So oxygen gas, which is O2. Here's the model for oxygen gas. Go ahead and tell me how many different elements do we have in this model? You're going to write that number right here. How many different colors do you see? Because remember, each color represents a different type of element. Now, how many atoms do you see? How many specific spheres can you count in this molecule of O2 gas? Okay, then I want you to count the number of bonds. How many rods or sticks do you see in this molecule? And you're going to write that number right here. If you need more time on this molecule, go ahead and pause the video. I'm going to move on to the next one. All right, nitrogen gas. Here. Okay. So here's nitrogen gas, N2. I'm going to do the same thing. How many different elements do you see? How many different colors are used in this model? How many total atoms? And then how many bonds? Remember, atoms are represented by the spheres. Bonds are represented by the sticks or those rods. Okay. If you need more time, go ahead and pause the video. I'm going to move on to the last molecule. And that one is nitrogen monoxide. Okay, so here's our nitrogen monoxide. NO is the chemical formula for nitrogen monoxide. How many different elements do we have in this molecule? How many different colors do you see? How about how many atoms? How many total spheres? And then count your bonds. How many sticks or rods do you see in this? I'm going to write this up here. Okay. And when you're finished, your entire chart on page 23 should be completed. Okay. All right, guys, thanks for listening. See you in the next video.